Okay, so this is just a little discussion about MATLAB assignment number 3. I'm recording it, and I will place it along with MATLAB assignment number 3 in Blackboard as a reference. So they talk about applications of Markov chains, and I'm not focusing on the code up there right now, but MATLAB exercises, if we look at the first exercise, it says that suppose we toss a fair coin, the probability of getting a head is a half, and you know you toss the coin many times. All right. At any point in time, we look at the outcome of the previous two tosses. There are 4 possibilities. So if I go to the next page here, here are the 4 possibilities. Okay, hold on. Here are the 4 possibilities. So the first head represents the head, T represents the tails on a toss, and these possibilities determine 4 states. 4 states. S1 is HH, S2 is HT, S3 is TH, and S4 is TT. Okay, so again, now for this first exercise here, okay, the 2 tosses together form those particular outcomes. And what they want you to do is they talk about states. Okay, so there are, and find the stochastic matrix for this problem. Okay, so there are 4 states. There are 4 states: S1, S2, S3, and S4. S1 is the state HH, S2 is the state HT, S3 is the state TH, and S4 is the state TT. So they want you to find a stochastic matrix for this particular problem. So to get you started on it, and this is something you would want to discuss this within your groups to figure out this stochastic matrix. But if we go to the whiteboard, okay, there are 4 states. So to help you with MATLAB assignment 3, the first exercise, okay, we'll have, HH, HT, TH, and TT. Okay, and then we have HH, HT, TH, and TT. Okay, so this is a 4x4 matrix. A 4x4 matrix. And you have to figure out what the 16 entries are. Okay, and for this. Now, to help you, to just give you a little bit of a guide here, okay, let's say you wanted to know what this, what's that value going to be? Okay, what's that value going to be? And basically, well, that value would be the probability of going from this state, HH, to this state, HH. And hold on here. remember what these states mean. Okay, remember what these states mean. So if I go back here to the document, I always have to go back and forth here. Okay, so you're looking at the outcome of the previous two tosses. So again, the previous two tosses, you have these four outcomes here. You have those four outcomes. Okay, so let's see how a sample transition would work. Let me go back to the whiteboard. So again, we're looking at that first entry in the top left-hand corner. All right, and you could think of this HH as the first, hold on, let me, okay, the way you want to think of this is first toss is a head, second toss is a head, okay, and you're going to that state was state S1, right? Right, that was, I believe, state S1. And you're going to a state where the second toss is ahead. Hold on. Second toss is ahead, and the third toss is ahead. Okay, so the first two tosses in this, I want to say this the right way. The question is, if you're in state one, okay, if you're in state one, meaning that your first and second toss of the coin were both heads, can you go from state one to state one? Okay, can you go from that state one, to state one? Okay, well, of course, to go from one state to another state, you have to flip the coin. So state one, let's suppose that your first and second tosses were heads, and then it's your previous, and then I want to say it the right way. You flip the coin. You're going to flip the coin 3 times. Okay, there's a first toss, a second toss, and a third toss. Let's say your first and second tosses were both heads, okay? And then your third toss was also a head. If you're going from state one to state one, if you flip the first 2 flips of the coin, you got heads. So now when you flip the coin again, your previous 2 tosses that were if you flip the coin the third time, your previous 2 tosses were a head and a head. Now you flip the coin on your third toss, and your third toss you get a head. So now your most recent tosses are second toss ahead, third toss ahead. And we want to know, is this transition possible? And if it is possible, with what probability? To go from a first toss being ahead, second toss being ahead, to the second toss being ahead and the third toss being ahead, what has to happen? What has to happen? Okay, Mikhail says ahead. That means you got, that's right, you got a head on the third toss. You got a head on the third toss. So this means then that, well, what's the probability of that? What's the probability of getting a head on the third toss? With what probability does that happen? You flip the coin twice, you get heads on both those tosses. Now you flip the coin again, and you get a head on the third toss. What's the probability of getting a head on the third toss of the coin? It's a fair coin. So what's the chances of getting a head when you flip the coin? 50%, that's right, Cameron. So the 50% is going to go here. This is 0.5. See that? Okay, now let's take another spot. Okay, again, there's 16 numbers you have to fill in here. Let's say that you wanted to find this probability here. Okay, all right, so there you're going from a head to, I'm sorry, that's not right. You're going from a head tail, please let me know if you have any questions. You're going from a head tail. So the first toss is a head, and the second toss is a tail. And that state there, you're going to, in this entry, you're going from the head tail state, which is the second state, S2, and you're trying to get to state 1. State 1 is at HH. So this would mean that your second, no, I want it in green, sorry. This would mean that your, hold on here. This would mean that your second toss was a head. I'm sorry, I got to get this, I want things to look good here. I want the writing to look good and clear. Second toss was a head, and the third toss was a head. Let's make sure all the writing is nice and clear here. Okay, so can this transition happen here? Can that transition happen? Can you get a first toss being a head, a second toss being a tail, move from that state to the state where the second toss was a head and the third toss was a head? Is that possible? So your first toss is a head, second toss is a tail. Can you go from that to the second toss being ahead and the third toss being ahead? And I appreciate all responses. For the transition to happen, notice for the first scenario here, right, you can't have, so for the first little example here, you can go from HH to HH because the first and second tosses are the same. But here, if the second toss is a tail, then it can't be a head. So this means this is not possible. And so what would the probability be in this spot here? What would the probability be? If a transition can occur from one state to another state, what's the probability that the transition would happen? If it can't happen, what's the probability? Well, probabilities can't be more than what? Probabilities can't be more than 100% or 1. So what this means here, is that state 2, going from state 2 to state 1, that can't happen, right? You can't go from state 2 to state 1. So what's the probability of going from state 2 to state 1? That's what I want a number in here. There's no chance that that can happen. If there's no chance that can happen, what percent chance is there if there's no chance? That's right, Marcella, 0. So you're going to have a 0 here. You see that? You see how that works? Mikhail, we'll have to talk about that. I'm not sure what that is. But what you have to do now is fill in the remaining 14 entries. And remember, this is a stochastic matrix. So it's a stochastic matrix, right? So, all right. Are there any questions on this particular exercise? This is exercise 1 from MATLAB assignment number 3. All right, great. Let me stop the recording then, if you're good. And what I'm trying to do, again, this recording, I'm going to place it with MATLAB assignment number 3 as just something you can refer to. Because you're probably not going to be working on this MATLAB assignment right at this exact moment, right? This exercise, you're probably going to wait a little while to do it, and being this is recorded, then you can refer to it. How many maybe referred to the recording on I did for the MATLAB assignment number 2, those exercises? Was it helpful? Okay, no problem. No problem. All right, well, good. All right. Thank you, Cameron. Appreciate it. All right. Let me stop the recording. Very good.